Let's find the derivative of this equation using implicit differentiation. On the left side of this equation, we have the term sine xy. To differentiate this, we're going to have to use the chain rule. To find the derivative using the chain rule, we multiply the derivative of the entire expression, or the outside, by the derivative of the inside. And in this case, our inside expression is going to be the argument of the sine function, xy. The derivative of the outside function, or the whole function, sine xy, is cosine xy, because the derivative of sine is cosine. And we multiply that by the derivative of the inside. Here, our inside expression is xy. This is a product, so we have to use the product rule. The first term in the product rule is f prime times g. Here, f is x and g is y. F prime is 1, and we multiply that times g, which is y. So f prime times g is y. And we add to that g prime times f. I'm going to go ahead and write the f function first, because f is just x. And then we multiply that by g prime. The derivative of g is dy over dx, because the derivative of y is dy over dx. And that gives us the derivative of the left side. Now let's look at the right side. We can differentiate the right side term by term. The derivative of the first term, x, is 1. And the derivative of the second term, y, is dy over dx. And remember, the name of this game is to solve this equation for dy over dx, because that is the derivative of y with respect to x. So let's start by simplifying the left side of this equation. Cos xy times y gives us y cos xy. And distributing to the second term gives us x times cosine xy times dy over dx. And the right side of our equation for now is unchanged. Now let's subtract y cosine xy and dy over dx from both sides of the equation, so that we have both terms that contain dy over dx on the left side of our equation. That gives us the equation x cosine xy times dy over dx minus dy over dx equals 1 minus y cosine xy. Now we'll factor dy over dx from both terms on the left side of the equation. Factoring dy over dx from the first term on the left gives us x cosine xy. And factoring dy over dx from the second term gives us minus 1. And the right side of our equation is still 1 minus y times cosine xy. Now to isolate dy over dx, we'll divide both sides of the equation by x cosine xy minus 1. And because the resulting fraction can't be simplified any further, this is our final derivative. Let's take a look at this example. Here we need to find the derivative using implicit differentiation of x cubed equals x plus y in the numerator over x minus y in the denominator. On the left side of the equation, the derivative of x cubed with respect to x is 3x squared. And on the right side, we have a quotient, so we'll have to use the quotient rule. The easiest part of the quotient rule is the denominator, and that's just g squared, or the denominator squared. And when using the quotient rule, the numerator is f prime g minus g prime f. The first term is f prime g. G is the denominator, which is x minus y, and we have to multiply that by f prime. F contains two terms. The derivative of the first term, x, is 1, and the derivative of the second term, y, is dy over dx. Now we subtract from that g prime times f. F is x plus y, and the derivative of g is 1 minus dy over dx. Now let's start simplifying the numerator. We'll have 3x squared equals 1 times x is x, and 1 times minus y is minus y. X times dy over dx is x dy over dx, and then minus y times dy over dx is minus y dy over dx. And we subtract from that x plus y times 1, and then x times minus dy over dx gives us minus x dy over dx, and y times minus dy over dx is minus y dy over dx. And that's all still over the quantity x minus y squared. And now we distribute the minus into the parentheses to get this equation. X minus x adds out. The minus y times dy over dx and the plus y times dy over dx adds out. Minus y and minus y in the numerator combine to give us minus 2y. And x times dy over dx plus x times dy over dx gives us 2x times dy over dx. And that's all still over the quantity x minus y squared. Now let's begin the process of solving for dy over dx by multiplying both sides of the equation by x minus y squared. That gives us this equation. And now we'll add 2y to both sides of the equation. And that gives us this equation. Now the only step left to solve for dy over dx is to divide both sides of the equation by 2x. And that gives us this expression on the left, which is our derivative of y with respect to x.